Good afternoon, everybody. Just let me know if you all can hear me, please. All right, cool. All right. So again, afternoon, everybody. So I'm streaming this directly on my maths channel, right? Most of you all should realize that I have a CSEC chemistry channel as well, right? And there's a lot of free material there that you all can access. Okay. Right, so in today's session, what I'm going to be focusing on, I'm going to be focusing on examination questions based on organic chemistry, right? Just to give a brief intro for those of you who it's the first time you're joining me here. So my name is Terry David, right? I'm a past national scholarship winner, right, in science. I do give online maths, chemistry and physics classes, right? My new Form 4 class starts in August, right? Those of you moving into Form 5, right? There is space available in those classes. You all can send me a WhatsApp at this number here, right? If anybody is interested in classes, right? With respect to chemistry, a long time ago, I got the highest mark in A-level chemistry, right? And that is Cambridge, right? We didn't have CAPE at that time. CAPE was now being introduced, so we had to do Cambridge. So let's get going. So CSEC basically gave some broad topics that are supposed to be being tested in the paper 2, right? These are the list of the topics that are supposed to be tested. Now, what I'm going to be focusing on today, I am going to be focusing on these two topics here, which is organic chemistry, an introduction, and reaction of carbon compounds, right? A lot of the examination questions that I've chosen to use today, right, they are different from what I have done with my online chemistry class, right? So I know we have some of my students here as well, right? So the questions I've chosen are questions that we have not covered in class. So the most recent papers we have covered in class, right? So I went a little further backwards this time, right? So let's start with this paper here. This is in June 2015, right? And one thing I want you guys to remember, organic chemistry is not as hard as people believe it to be. Organic chemistry is the easiest part of the entire chemistry syllabus, right? I am telling you that, and that is the truth, right? If you learn your organic chemistry, right, you are going to get 2 questions in the paper based on organic chemistry. So if you learn your organic chemistry very well, then you'll be able to handle yourself in the paper and achieve a higher grade than you would have, right? So we have a question here. The fully displayed structures of 2 carbon compounds, hydrocarbons, sorry, compound A and compound B are shown in the diagrams below, right? Name the homologous series to which compound A and B belong to, right? Now, what do you all think compound A belong to? Tell me what does compound A belong to and what does compound B belong to, just by looking at the structure. So I'm seeing Sharice is telling me compound A belongs to alkanes, B belongs to alkenes. So let's see if that's correct. So compound A, this is compound A here, and if you look, this compound only has carbon and hydrogen, but there are only single bonds. So what that tells me is that compound A belongs to the homologous series called alkanes. That is what this belongs to. In the case of compound B, if you look carefully, you realize, wait a minute, this has a double bond, right? Now the fact that it has a double bond means that this compound is an alkene, right? So again, 1 mark each for that. So if you knew the structures, that's an easy to mark that you can get. Now, in terms of naming the compound, the name of compound A, right? I think I saw somebody put their answer inside the chat already. Somebody said something, 2-methyl-butane. Let's see. So here's how what you have to do in order to name your organic compounds. The first thing we need to do, we need to identify our longest carbon chain, right? So you have 4 carbons there. So therefore, that's the root of my name. So that's but, it's an alkene, so it's something butane, right? Now the thing is, when you have branches attached to your main carbon chain, this here is my CH3 branch, right? And that branch, because it has 1 carbon in it, it's called methyl, methyl, right? Now you need to indicate where is this methyl connected to the main branch. Now what you have to do is to number your longest chain. So you can go 1, 2, 3, 4, and then somebody might come and tell me, sir, but you can number 1, 2, 3, 4, and that is absolutely correct. But what you do, you number your longest carbon chain so that the number where the branch is located is the smaller number. So you notice here, you have a 2 and you have a 3. So what we're going to say, we're going to call this compound 2-methyl-butane. That's the name of this compound, 2-methyl-butane, right? So that's the name of compound A. In the case of compound B now, you have a double bond. So you know this compound is an alkene, but it has 4 carbon atoms. So therefore it is but. Right? When you have 4 carbon atoms, the root name is going to be BUT. Now here's the thing, when you are naming alkanes, please guys, if you just put butene, CSEC is going to give you that wrong, guys, right? Be careful with that. You cannot just put butene, right? In the past you would have been able to get away with that, but now you can't. What you need to do, you need to indicate the position of your double bond. So if you look carefully here, our longest carbon chain needs to be numbered. So 1, 2, 3, and 4. So the name of this compound here is actually called but, right, dash 2, because the double bond is located on my second carbon. It's butene. So that's one way I can name this compound, or I can call it 2-butene, right? So be careful. And this applies to alkenes as well as alcohols. So don't just rush and say butene is the name, right? You're going to get it wrong, right? So moving on, that's the name of the compound, right? So I'm going to try to cover as much questions as I can cover in this session, right? Now the next part here, they want us to define the term structural isomerism, right? Now organic compounds, right, they you can have different forms or different structures of organic compounds that have the same molecular formula, right? So different compounds, they can have the same formula, right? But they can have different structural formula, right? So that's what an isomer is. So structural isomers are organic compounds that have the same molecular formula but different structural formula, right? So structural isomerism. Let me just put it here because we may encounter this several times, right? So let's just type it in one time here. So structural isomerism, right? Organic compounds having the same molecular formula but different structural formula, right? So that is what structural isomerism is, right guys? So I'm sure we're going to encounter this question several times, so I'm going to keep it here so we can just copy, right? So this is what structural isomers are. They have the same molecular formula but different structural formula. Now they said draw the fully displayed structure of one structural isomer of each of the compounds. So look at something here. So So let me just erase this here. Let's erase this so you can see the compound again. So this is compound A. This is my compound A, right? And this is my compound B. And what they want us to do, they want us to draw isomers of each of these compounds. Now let's do compound B first, right? Let's do compound B first. When you have an alkene and you want to write an isomer or draw an isomer of it, all you need to do is to change the position of the double bond. So you notice the double bond right now is between the second and the third carbon atom. This is where your double bond is. What I'm going to do is just shift the double bond. So if I shift the double bond, right, then it's going to become this. Now please be careful when you're drawing these diagrams. You must only have 4 bonds around any carbon atom, right? So look at my diagram here and you're going to see that each carbon atom only has 4 bonds. What students, they make a mistake by doing, especially when it comes to the double bonds, they put an extra bond here, which is incorrect, because what you're doing, you're introducing 5 bonds around the carbon, right? Now they want us to draw, right? They didn't ask us to name the isomer. So this is for compound B on the right hand side. In the case of compound compound A now, right? You want to draw an isomer of that. Now what they've drawn in compound A is a branch isomer. So what we can do, this has 1, 2, 3, 4, 5 carbon atoms. So all I can do here, or the easiest thing I would do here, is do this. 1, 2, 3, 1, 2, 3, 4, 5, and just draw this. And I'm getting 2 marks for this. This is not taking me long in the exam to do. So organic chemistry, like I said, it is very easy if you learn your work, right? So this here is my structure, and look at that. I'm getting 4 marks just to draw these 2 structures, sorry, right? 4 marks just to do that. Right, so I'm now checking the chat here. So Daryl and Adisha and and Ashish, you all have the general gist. That's essentially what it is. Same organic compounds which have the same molecular formula, different structural formula, right? So let's see what we have here now. The next part here now, they said polyethylene is manufactured in Trinidad and is used extensively throughout the Caribbean, right? So I feel I should type this one because we may encounter this as well, right? A polymer, you all have to be able to define what a polymer is, right? Now a polymer, it's a macromolecule, guys, right? So a polymer is a macromolecule, right, consisting of, that's not, missing something here, that's not, polymer is a long chain macromolecule consisting of many repeating units called monomers, right? A simple definition like that will give you full marks in the exam. So make sure you know what a polymer is. So a polymer, right, will look something like this. You will have many repeating units joined together, right? So more than 30 or so units, right? So this is what a polymer looks like. It's a long chain macromolecule, right? Each one of these things here are what we call monomers. So this here is a monomer, right? Now the monomers could be the same or it could be different, right? But essentially that's what it is, a whole set of repeating units, right, to form the polymer. Now the next part here, identify the type of polymerization used in the manufacture of polyethylene, right? So what kind of polymer is polyethylene? Alright, listen, I'm going to go back a sec. I saw you all say I'm missing something here. Oh yeah, sorry. Yeah, you all are correct. I'm missing an H here. Alright, my bad. Right, so I've seen Daryl saying it's an addition polymer. That is correct, right? Polyethylene, right? Identify the type of polymerization, so it is addition. So you all need to remember we have two kinds. We have something called addition and we have condensation. In the case of polyethylene, sometimes you may be asked to draw, right? How do we get polyethylene? So polyethylene starts off with a monomer called ethene. So this is my monomer, and we have n of those, right, combining, right, usually under high temperature. Catalyst may require some kind of pressure, and what's going to happen here is that we get polyethylene being produced. Now I'm going to draw this using 2 repeat units, right? CSEC can ask you to draw 1 repeat unit or 2 repeat units, right? You need to know what that means. If you look carefully, this particular diagram that I'm drawing here has 2 repeat units. Right? So this compound here is called polyethylene, right? So addition polymers, when it comes to addition polymers, look out for alkenes as your starting point, right? So let's see what else they want. They want state 2 uses of polyethylene. Could you all give me some uses of polyethylene? Right, and I've seen any examples coming in here for polyethylene. Polyethylene is plastic, right? Polyethylene is plastic. So any so plastic wrapping, right? When I say plastic wrapping, you know, in the kitchen you have cling wrap, right? So cling wrap, that's polyethylene, right? Plastic cups, right? Plates, right? So basically anything plastic related, plastic bags, you name it, right? So any 2 examples and you're good to go. Now they said name one other polymer, right? One other polymer. Could you all give me another polymer? Right, so I've seen a set of different examples coming up here and they are all correct as far as I can tell. So they want other examples. So I see some of you all saying polystyrene, polyvinyl chloride, Teflon, polysaccharide. Yes, all of those that you all are given there are correct, right? So you have polyvinyl chloride, right? Polyvinyl chloride is PVC, right? PVC. You all said polystyrene, right? You also said Teflon, right? You also have terylene, right? You also have nylon, right? So basically one mark. Any other polymer and you're good to go, right? So that's a question from the 2015 paper. Let's go on to January 2015. And they want us to name 2 natural sources of hydrocarbons, right? So they've asked this question many times before, right? So you can say petroleum, right? Or crude oil, right? Also natural gas, right? So these are examples or 2 natural sources of hydrocarbons. So they've asked this question in the past, right? Now this next one here. According to your syllabus, you all need to be able to know at least 3 fractions from the fractional distillation of crude oil, right? So crude oil in its raw form, right? Crude oil in its raw form is not very useful. What we need to do, we need to take that crude oil and we need to separate it. Crude oil is a complex mixture of hydrocarbons, right? And what we make use of is the fact that the different components, they have different boiling points. So what you do, you heat the crude oil, right? The lightest fractions are going to come out at the top of the fractionating column, and the heaviest fractions come out at the bottom. Now, you all need to understand or know the different fractions. Your syllabus says that you need to know 3 fractions, and you need to be able to give examples of the uses of those fractions. So the first part here, they said fraction number 1. So they give you a table, and fraction number 1 goes from carbon 1 to carbon 4, right? So carbon 1 to carbon 4. That's what they want us that's what they want, right? So for fraction 1, right, is what we call refinery gas, right? So this here, so they said identify one of the numbered fractions, right? So fraction 1, so I'll give you all of them. So fraction 1 is called refinery gas. Right? And that's the fraction that comes out at the top. The next fraction here, right, which is C12 to C18, right? C12 to C18, right? You can put kerosene as that fraction if you want, right? So this here, right, is called kerosene. Now CSEC accepted several different answers for this particular question when it was set, right? So fraction 2, we're gonna call that kerosene. Now if you all had put jet fuel, heating fuel, diesel, paraffin oil, you would have been given a mark, right? So, and the last fraction, the third fraction, right, that's C20 to C14, right? We're going to call that fraction bitumen, right? So the third fraction, we're going to call that bitumen. So they just said you have to choose one, right? So you choose any one you want and give it a name. So if you choose 1, you have to call it refinery gas. If you choose 2, you have to call it kerosene, and if you choose the third one, then you have to call it bitumen. Next part, they want state one use of the fraction 3. Fraction 3 is bitumen, right? So you all should know what we use bitumen for, right? In the case of bitumen, right, we use that for road surfacing, right, and also for roofing material, right? So they want a use, so we can say road surfacing, right? So we use that a lot to pave our roads. So here in Trinidad we use asphalt and bitumen to pave the roads, right? So road surfacing or in roofing as well, right? So 1 mark just for stating that. 1 mark for that. That's no biggie. Next one here now. So we have a compound here. Compound W has a characteristic odor pairs and is used in fragrances and as a food additive, right? Identify the homologous series to which this compound W belongs. What does compound W belong? right? So, well, you all seem to know your work, right? I see everybody saying esters. That's correct, right? So they want to know the name of the homologous series to which it belongs. This belongs to the ester group, right? And how do I know that? It has to do with, you see this group here? This here is my ester group. So it can be drawn like this, right? So this is what we're looking out for. This here is called my ester linkage, right? So this is the ester group, right? So 1 mark just for stating that. And also a hint that you all should pay attention to when it comes to esters. You see when they say it has a smell, has an odor, pairs, and it's using fragrances, right? That tells us one time, hey, that's an ester, right? That's a hint that CXC normally uses. So they might say sweet smelling oily substance. That's an ester. Now, here's what I want here. Write the fully displayed structural formulae of 2 molecules that are produced when W is hydrolyzed with dilute hydrochloric acid, and state the name of any one of the structures. Now, here it is. To make an ester, we need an organic acid. So you need an acid plus, right, an alcohol, right? Now this reaction here is a reversible reaction, and what we get is an ester, and we get water being produced, right? Now this particular question comes almost every any multiple choice. An organic acid, so let's put the word organic here. So I've got organic acid plus alcohol. That forward reaction is what we call esterification. The reverse reaction is what we call hydrolysis. So this here is called hydrolysis, right? So the reverse reaction. So when you take the ester and you react it with water, right, what's going to happen is that you're going to get back your organic acid and your alcohol. So that's what hydrolysis is. Now there are 2 ways you can use, or 2 ways we can perform hydrolysis, and that is 1, we can do acid hydrolysis, and 2, we can do alkaline hydrolysis. Now I want you to remember something. Depending on what you use, you get different products, right? Students don't realize that, but you can get different products. When we do acid hydrolysis, like in this question, because they told us that in the question, if you go back to the question here, they said we use hydrolyze using dilute hydrochloric acid. When you use the acid, what you're going to get back, you'll get back your organic acid, and you're going to get back your alcohol. So what we're going to do, we're going to break up the structure here, right? Now this part here of the structure will be my acid part. This here is my acid part. And this part here gives me my alcohol part. Right? That's what's happening here. So you have an acid part and an alcohol part. So they want us to draw the structure of what we're going to get. So the acid part here is going to contain 2 carbon atoms. So let's draw that. So you're going to draw 2 carbon atoms, 1, 2, and you're going to draw your acid, which is going to be this. So this compound here is one of the products. That's compound A, and that's an acid. The next substance we're going to get is the alcohol. But this alcohol here has 3 carbon atoms. So therefore we're going to go 1, 2, 3, and you're going to draw your alcohol, draw it on this side, right? So this here is my alcohol. So these are my 2 compounds that I'm going to get when I hydrolyze that particular ester here, right? This is my alcohol. Now they want us to name, they said choose one of the structures and name them. This first one here, you have 2 carbon atoms and it's an acid. So the name of this compound here is ethanoic acid, right? That's the name of this compound. This is ethanoic acid here. The compound on the right now, you have 1, 2, 3 carbon atoms. So the root name is going to be prop, right? But you have to be careful, guys. When you are naming alcohols, don't just go and tell the people propanol. They're not going to give you that correct. You need to say that this compound here is called 1-propanol. That's the name of this compound. Or we can say prop and -1-ol, right? Do not go in the exam and put propanol. You are not going to get a mark, right? So you might be thinking, yeah, I get correct one. But that's not what they want. They want 1-propanol or propan 1-ol. You are indicating the position of the OH group. That's what you're doing, right? So they ask you to name either. So either you're naming A or you're naming B, and you're going to get marks for that, right? So next one here now. Let's see what they want here. So part D now, they said glucose, a monosaccharide, can be represented. So they gave us a symbol to represent the glucose molecule, right? It could be a little complicated and you're not required to know what the actual glucose molecule looks like at this level. Say the name of the polymer of glucose, and using 3 glucose units, draw a partial structure of this named polymer in the space provided, right? So they want to know what is the polymer of glucose. So when glucose molecules combine to form a polymer, that polymer is called starch, right? So this is in your syllabus, you need to know this. Starch is my polymer. Now, they want you to draw the partial structure of the glucose. Now, here's what's happening here. So they gave us something here. You have OH, you have OH, right? And remember, you want to form a polymer. So this is what's happening, right? What is going to happen is that one of the OH and the H from our next molecule is going to come out, right? And this is going to come out as H2O. So therefore, this is a condensation, polymerization taking place here. So the structure or the partial structure of starch is going to look like this, right? That circle that they gave us there. And what's going to happen is that you're going to have an oxygen in between those different particles there, right? So this here, how many units I wanted? They just say a partial structure, right? So I'm gonna just shade this so you can tell the difference, right? So this here is this piece I'm drawing here, right? And that O in the middle is my oxygen, right? So you have what they call the eta linkage between your the glucose molecules, right? So this is the partial structure of glucose, the polymer of glucose, right, which is starch. So this diagram here is how we represent starch, right? So 2 marks just for that, right? Now the next part here now, a student is asked to distinguish between a sample of glucose and the polymer. He adds water to separate portions of glucose and its polymer and stirs. State the expected observations in each case. Now sometimes the physical and the chemical properties of your monomer and your polymer are different. Now when it comes to glucose and starch, glucose, right, is a solid, right, a white powdery solid, right, and starch, right, looks a little different, right, but here's the thing, they are adding portions of each of them to water. Now glucose is very, very soluble in water, right? So they want the observation in each case. So glucose dissolves in water. So that's my observation here for this part. Glucose dissolves in water. In the case of the polymer here, the polymer we're talking about is starch. Now starch is something that is insoluble in water, right? So you need to say starch, right, is insoluble in water, right? So starch is insoluble in water, right? So 1 mark for each of those there. That's what they're looking for that answer. So that's part D. Do we have anything else for that? Oh, we have a part E now, right? So you have a monomer and it undergoes, so they're telling us that this monomer undergoes a condensation polymerization. Name the polymer formed and give one use of this polymer. So you have to look at the structure here. This is a monomer for some compound. Now let me draw what the polymer is going to look like for this compound here, right? So you have your double bond, then you have your O, right? But if we bring a molecule like this close to it, right, what's going to happen is that this is, oh wait, sorry, I missed out something here. This is an H here, OH, right? So what's going to happen is this OH and this H here is going to come out as water. So that's why it's a condensation polymer, by the way, because water molecules are being eliminated in the process. So what's going to happen here is that you're going to get a bond that is going to look like this. Watch how your bond is going to look. You're going to have C double bond O, right? Then you're going to have an N here, H here, and then you have the structure repeating again, right? So you see this here, let's draw a little, this here, this particular bond here, this is what we call our amide linkage. So this here is called my amide linkage, right? And by the way, they ask you this in the multiple choice. Sometimes they draw the diagram of the linkage and ask you which of the following represents the amide linkage. So that particular amide linkage is being present here, right? That's what's happening here. So what's the name of this type of, what's the name of this compound that we get in here, guys? What type of polymer are we getting in this scenario here? Anybody want to take a guess? What type of polymer am I getting here? Right, so somebody said polyamide. That is absolutely correct. So this is what we call a so this here is a polyamide, right? So this is a polyamide, right? Now this polyamide here, we have to be able to give a use, right? Now an example of a polyamide could be nylon. Nylon is an example of a polyamide, right? What do we use it for? We use it to make rope, we use it to make clothes, we use it to make carpets, brushes, right? So any one of those answers will work. So a polyamide in this case here, right? This is what a nylon structure looks like. So the polymer called nylon, it looks like this. So what do we use it for? So we use it to make ropes, right? Now there's one example, right? Ropes, carpets, right? Paint brushes, right? So you just, and also clothing, right? So you just want one example here or one use and you're good to go, right? So that's January 2015. Now I made a step back here to January 2020. So in the January 2020 paper, they want you to name 3 characteristics of a homologous series, right? 3 characteristics of a homologous series, right? So by the way, that particular topic, right, is in the introduction to organic chemistry, right? You need to know what are the properties of a homologous series, right? So I'm going to give you what those are, right? You just need to learn them off. There are several properties of a homologous series, right? And I have them all here for you guys, right? So the first one, they only want 3, right? But we have several we can choose from. So the first one, they all have the same general formula, right? So all members of a homologous series, they have the same general formula. So some of you all might be saying, what is a homologous series? These are the ones you need to know for your exam. You need to know the alkanes. You need to know your alkenes. You need to know your alcohols, right? You also need to know your carboxylic acids, right? Well, let me use the correct word here. It's called alkanoic acid. So you need to know alkanoic, right? Or carboxylic. Acids, right? You also need to know about esters, right? So these are the homologous series that you need to be familiar with, right? So they have the same general formula. They have similar chemical properties and physical properties. Sorry, similar chemical properties. I said that wrong. They have similar chemical properties, right? They also have the same functional group. Now it's because of the fact that they have the same functional group allows them to have similar chemical properties, right? So functional group and chemical properties are related. So sometimes in the exam they might ask you, what is a functional group? A functional group is simply, right, an atom or a group of atoms that determine the chemical properties of an organic compound, right? That's what a functional group is. Now, the next one here, they have a gradual change in physical properties. Now, what that means is that members, or the first few members, might be gases, then the next few might be liquids, and then it might change into solid, right? So there's a gradual change in physical properties within the homologous series, right? So they don't have the same physical properties, there's a change. So your boiling point can increase, your melting point can increase, your viscosity can increase, all right? So those are physical properties. So your physical properties, they vary, chemical properties are the same. The next thing is that each member differs by CH2 units, right? So let's say, for example, you have, let's say the alkane homologous series, right? The first member is methane or methane, right? The next one is going to be ethane, sorry. And the one after that, right, will have 3 carbon atoms. So it's 1, 2, 3. I just realized the video might be blocking this one, right? But what is happening here, if you realize the difference between your structures, right? Look at the structures. What you're doing, the difference between the first and the second structure is CH2. The difference between the second and the third one is the next CH2. So we keep adding on CH2. That's where this came from, right? That's what you do it. And one more is that they can be prepared by the same general method, right? So if you want to produce an alcohol, it's the same method we're going to use to produce the alcohol, right? No matter what it is, right? So all you wanted was 3, and they love to bring this in the multiple choice, guys. So make sure you know these. Make sure you know these. So 3 marks for that. Any 3 they want. Now the next part, they want you to draw the fully displayed structural formula of compound A. So compound A, if you're not seeing it properly here, it is C3H8, right? Fully displayed structure of this compound here, C3H8, right? Now that's an alkane. So for 2 marks, it's an easy 2 marks here. So you're going to draw 3 carbon atoms, and you need to put 8 hydrogen around it. So this is it here for 2 marks. That's taking you less than a minute to draw. Right? So this is my compound. Draw the fully displayed formula. Easy 2 marks. Next part here. State the homologous series to which this compound belongs. So C3H8, if you look at this compound here, all you have is carbon and hydrogen present, and there are only single bonds. There are no double bonds here. So that automatically tells me here what? This is an alkene. That's what this is. It's an alkene. Right? Now, the next part here now, they said write the formula of the compound which has 5 carbon atoms. So, if you need to answer this, you need to know the general formula. So, the general formula for an alkene is CnH2n plus 2. That's the general formula for an alkene. Right? But in this case, we have 5 carbon atoms. So it's going to be, here's what you're going to do. C5H, and you're going to plug it into the formula. So it's 2 multiplied by 5 plus 2. So therefore, this compound here is going to be C5H, 5 2s are 10, plus 2. So therefore, the formula for this compound is C5H12. Right? That's the formula for that compound here. Okay? So again, that's easy marks for you guys, right? C5H12. The next part, they want us to draw compound B, and the formula for compound B is C3H6, right? So this compound here, we're going to draw 3 carbon atoms. So put 3 carbon atoms, but the thing is, you realize you only have 6 hydrogen, so that tells me that there has to be a double bond somewhere inside it. Right? So this is the only way I can get that formula of C3H6. Right? All they want us was to draw the structure. They didn't ask us to name it. So they just want us to draw it. Again, easy 2 marks. So compound B now, they said what homologous series does this belong to? Well, it has a double bond, so therefore that's an alkene, right? So this here is simply an alkene, right? That's an alkene. Now, the third part now, they said write the molecular formula of the compound which has 5 carbon atoms. Now, in order to answer that, you need to know the general formula. The general formula for an alkene is CnH2n. So, if we want one that has 5, it's going to be H2 multiplied by 5. So, therefore, the formula for this compound will be C5H10. That's my formula. So, the organic compound that has 5 carbon atoms will have a formula C5H10. Right? Now, here's what I want here now. For each of the following homologous series, write the general formula. So, in this question, they're testing everything. They want us to know about general formula. So, for a carboxylic acid, right? And by the way, a carboxylic acid looks like this. It has something called an R group with a COOH attached to it. Or, it can be drawn like this. C double bond O, OH. Right? This is how we represent an alcohol. Sorry, carboxylic acid. So, in the case of the carboxylic acid, the general formula is this. CnH2n plus 1, right? COOH. That's my general formula for a carboxylic acid, right? In the case of an alcohol, we usually represent the alcohol like this. ROH, or you might see us draw it like this. R-O-H. Right? That's how we represent an alcohol. So that R group that you see me attaching it, right? So that R group has a general formula of CnH2n plus 1. So anytime you see chemistry talking about an R group, it's called the alkyl group, ALKYL, and it has a general formula of CnH2n plus 1. So in the case of the alcohol, it's going to be CnH2n plus 1, and we just put an OH at the end. So 1 mark each for those, right? 1 mark each for those. So that is January 2020, right? So remember, I told you all you typically get 2 questions in the paper. So, right, so there's a second question here now. So, you have a compound C. Look at the words there. Sweet smelling. Right? Using flavoring, perfumes. Before I even read the question, I already know they're talking about an ester. Even if I don't know what the structure looks like, I know they're talking about an ester. So, look at this. You have the ester linkage here. Right? That's the ester linkage present. So, here's what I want. And please make sure you're answering what is being asked. Say the name of compound C. And they want the homologous series to which it belongs. So, compound C. We need to figure out the name. Now, an ester, right? I told you in one of the previous questions, an ester is made up of an acid, it's an organic acid, and it's also made up of an alcohol. Right? That's how we make the ester. Now, they want the name of the compound. Now, when you're naming the ester, this is what you need to remember. So, when you're naming an ester, right? The ester name is made up of 2 parts. Now the first part of the name is, it comes from the alcohol. So the first part of the name comes from the alcohol, right? Plus, the second part of the name comes from your acid, right? So in this particular case here, if you look carefully, the alcohol part, it only has 1 carbon atom, right? So therefore, this here has to be, 1 carbon has to be methyl. So this here is methyl, right? And we're adding that to my acid. In the case of the acid here, you have 3 carbon atoms. So that's met-eat-prop. So that is propanoic acid. So therefore, from the acid part, this is going to be propanoate, right? So this is how we name an ester. So the name of this ester here is called methyl. So the name of this compound C is methyl propanoate. Right? That's the name of this ester here. Right? And what homologous series? So it's an ester. Right? So bear that in mind. That's how we name an ester. The first part of the name comes from the alcohol, and the second part comes from the acid. Right? So it is methyl propanoate. Right? I saw some of you all have that. Great. That's correct. Now they said draw the fully displayed structural formula of two molecules that are produced. So look, similar to the question we just did, we are hydrolyzing this ester this time, right? So what you're really doing, you're breaking up the ester into its alcohol and its carboxylic acid. So the acid has 3 carbon atoms, so let's draw that. So 1, 2, 3. So we go ahead and we draw our acid. Our acid is going to look like this. So when we hydrolyze the ester, this is what I'm going to get. That's one product I'm going to get. They want the 2 products that we're going to get, right? The next one we're going to get is the alcohol part, which only has 1 carbon atom. So this is O, this is H. So this here is my second organic molecule that I'm going to get, right? So this here is propanoic acid. And this here is methanol. Right? So those are my 2 molecules that I'm going to get when I hydrolyze the ester. Next part now. Ethanol is widely used as a solvent for making cosmetics and perfumes. Right? Now they're showing you a reaction here. You're going from ethanol to compound D. So if you look at what's happening here, you started off with ethanol, and the compound D here, right, is a carboxylic acid. How do I know that? You see this group here? This is a carboxylic acid, right? So this here tells me that this is a carboxylic acid. That's what this is, right? Now, we're going from ethanol, and you're converting the ethanol into an acid. So the name of this compound here has to be called ethanoic acid. So this here is ethanoic acid, right? Now, what do they want? State the name of compound D. So the name, right, we already wrote the name there, it's ethanoic acid. Right, that's the name of that compound. Identify the reagent and the conditions necessary to convert ethanol into compound D. Right? Any of you all remember what that is? What are my reagents and conditions? Alright, so hold on, you all said I missed out a question. Let's go back. Let's go back. Oh, sorry, yeah, I didn't see that there. I missed that completely, right? Name the first member of, they said name, right? Name the first member of the carboxylic acid group, right? So the first member only has 1 carbon, so obviously the name of that is going to be methanoic acid. Right? Yeah, I missed that there completely, right? So methanoic acid is my first acid, and then in the case of an alcohol, right, it's going to be methanol. Right? They said name it. They didn't want us to give a formula, so just put methanol. Right? Yeah, that's my bad. I missed that completely. So this one here, this is what I want to know. I want to know what are my reagents and conditions required to convert ethanol into ethanoic acid. So somebody saying oxygen is the oxidizing agent. So when it comes to oxidizing agents, right, so here's what we can use. So we can warm So that's a condition. You can warm with acidified, right, potassium dichromate 6. You all need to know that this is an oxidizing agent. Sometimes we write it like this. We say H plus, right, K2Cr2O7. That's acidified potassium dichromate 6, right? If they were to ask you what is the color change, when it reacts to the ethanol, it changes from orange to green, right? But they said conditions and reagent. So my reagent is acidified potassium dichromate 6, and my condition, we're going to warm, right? You have an alternative that you can use, and that is just add acidified potassium manganate 7, right? Add potassium manganate 7. You don't even need to warm, right? Because potassium manganate 7 is an even more powerful oxidizing agent than acidified potassium dichromate 6. So sometimes you write it like this: H plus KMNO4. This is the purple thing that you would have used in a lab, right? It's a powerful oxidizing agent, and when it behaves as an oxidizing agent, it changes its color from purple to colorless, right? So let's move on here. We have okay, so we moved on to January 2021, right? So this is the most recent exam paper here, guys, right? So they said 2-methyl-butane and pentane have structural formulas. So they're telling us what the structural formula is, right? Which is C5H12. So C5H12. And they want us, first thing, what is structural isomerism, right? So structural isomerism, we got that previously. So I'm not going to type that back. I'm just going to pull the answer that we had before. And that's from here. Let's go back, and we're going to just put that here. Boom. Right, so make sure you know what structural isomerism is, right? So you're getting 2 marks for that, right? What else they want? They want us to draw the fully displaced structure of 2-methyl-butane. Now we kind of met this in a previous question that we just did. So you look at the root name. The root name is butane. So you're going to put 1, 2, 3, 4. That's 4 carbon atoms. When we see but, that tells us 4. Now it's 2-methyl. So that tells me it's a branch, and it has a methyl on that branch. So what you can do, you can put this here. CH3 is my methyl group, and it's on my second carbon atom. So therefore, 2-methyl-butane could look something like this. So this here is 2-methyl-butane, right? Now you could have put this CH3 above if you want. It doesn't matter. It's the same structure either way. Oh, I see you all asking about specific temperature for the potassium manganate. You don't even need to warm it, right? You could say at room temperature. That's a condition, right? But if you put warm, you're not going to get it wrong. So if in doubt, put warm. Alright, so where am I now? Alright, so that's that. And what I want, draw and name one other structural isomerism of C5H12. Well, if I were you, all I would do is do this, right? So there is a finite amount of questions that CSEC can ask when it comes to organic chemistry, guys. So if you do about 10 years of these, any question they ask you, you'll be able to answer. 1, 2, 3, 4, 5. So this here is an isomer, a structural isomer of C5H12. Right? So you can just draw this. And they want you to name it. This is a straight chain we've drawn. And you have 5 carbon atoms. So therefore, the name of this compound here is pentane. Right? That's the name of this compound. This is what I would have chosen. It's an easy way out. Right? So pentane is an isomer. Right? Next one. What do we have here? Ethanol can undergo various reactions. Depending on the reagents and conditions of the reaction, products with different functional groups can be formed. What is the functional group present in ethanol? Right? So when they ask you what is the functional group, in an alcohol, you see this OH here? That's my functional group, but it has a special name. Right? So you can say, that's my OH group, but it has a special name. It's called the hydroxyl group. Right? That's the special name here. So if you look at a lot of skincare products and hair products, you might see, if you look at the names of the substances that you find in them, you're going to see hydroxyl something inside it. Right? You're going to see the OH group a lot. Now, what are they asking us here now? So table 2 summarizes the conditions and products of 2 reactions of ethanol. Right? Complete table 2 by inserting the reaction conditions and drawing the fully displayed structure of the products when formed. So, there's no reagent here that is saying for this particular reaction we're talking about. And you are converting, so we're starting off with ethanol. That's what we're starting off with. But you want to produce an alkene, right? Now, this is what ethanol looks like. Right? You can put the OH here or you can put it on the side, it doesn't matter. But what I'm doing, I am taking this ethanol here and I am converting it. They said you're converting it to an alkene. So what's going to happen, that H and that OH is going to come out. Right? And what you're going to end up with is this compound here. This is the alkene that I'm going to get. Right? It's called ethene. So this here, for 1 mark, is this compound here. Right? Now, in terms of my conditions now that particular reaction here, right, is what we call a dehydration reaction. Right? When you convert an alcohol into an alkene, it is called a dehydration reaction. That's what it's called. Right? Now, in terms of how we doing that, right, we need to use concentrated sulfuric acid. That's our reagent, and my condition is 170 degrees Celsius. So here's what you need. Now they put, make sure we're doing this correctly here. So we have ethanol. Now I don't know why I didn't put reagent here, right? But what we're going to do here, we're going to use concentrated sulfuric acid, right? 170 degrees Celsius. That's what we're going to use. That's how we convert ethanol into ethene, right? So the name of this compound here is ETHENE. Now notice they're giving it 2 marks here. So therefore you're probably getting 1 mark for saying concentrated sulfuric acid and 1 mark for saying 170 degrees Celsius. Now, so in the second one here now, we are using a reagent. So remember you're starting off with ethanol, right? Which is CH3, CH2OH. This is one way of writing the ethanol formula. So you're taking ethanol and you're reacting it with this compound here. That's my reagent. So this compound here is ethanoic acid. Right? That compound is ethanoic acid. So, and look at what we're producing here. We are producing an ester. So they're expecting us to draw what this ester is supposed to look like. So when you're drawing your ester, you always draw your acid part first. So my acid part was ethanoic acid, right? And we are reacting with ethanol, so therefore the alcohol part should only have 2 carbon atoms. So this here is my ester. This is what I'm going to get as my ester. And the name of this ester, they didn't ask us that, but the name of this ester is called ethyl ethanoate. Right? That's the name of this ester here. It's called ethyl ethanoate. That's what this ester is called. Right? Now, we have to be able to give what are the reagents and the conditions in order to do that. Right? So that's one of the things that is extremely important when it comes to organic chemistry. You all have to be able to state what the conditions are. So all we're going to do here, we are using concentrated sulfuric acid as my catalyst, and we are warming this, or we're heating under reflux, right? So you're going to use concentrated H2SO4 catalyst. That's what you want here, right? And we are heating under reflux. Right? That's how we do, or that's how we convert, or how we produce an ester. Those are my 2 conditions. I need concentrated sulfuric acid as my catalyst, and I'm heating this under reflux. Right? We're still in the January 2021 paper. So they have some reactions taking place here. We have compound A, compound B, compound C, compound D. Right? And here's what they want. Now, listen, let me see if I can put this next to the diagram so that we don't have to go back and forth. So here's what they want. They want us to name, so let's put this on the side here. They want us to name what type of reaction is taking place in each of these things here. So look at the reactions here. Tell me, what do you call reaction 1? This here is reaction 1. What do you call that? Faith is asking me what is reflux. When I finish this question, let's go back to the next slide, the previous slide, and I'll tell you what reflux means. So tell me, look at this, what is reaction 1? So if you look carefully, what is happening here, right? You are converting an alkene into an alkene. That's what you're doing, right? Now, please don't confuse the words, right? I'm looking at some of the answers here, and nobody has given me the answers yet. So you're converting an alkene into an alkene. You see that process? This process is called hydrogenation. Hydrogenation. That's what we call that reaction. When you add hydrogen to an alkene, it is called hydrogenation, right? So that's the answer for that particular one, right? If you put addition reaction, they may give you the mark, but more specifically, it's called hydrogenation. Next thing, so that's part 1. They want to know what is reaction 2. Reaction 2 is this one here, right? So right, so I think I saw somebody said addition, right? So that's what we will put for this one here. That type of reaction here is called an addition reaction, because what's happening here is that you notice the double bond disappears, and we have 2 BRs, look at BR here and a BR here, attaching itself to the carbon atoms. So this is called an addition reaction. The third reaction, right, that is this one here. You are taking your alkene and you are producing carbon dioxide and water, right? So you're producing carbon dioxide and water. That particular reaction is known as a combustion reaction, right? So this is known as a combustion reaction, right? Now, Some of you all said addition, and I saw you all put something else. You could say halogenation as well, right? Halogenation. Yeah, that's true. You could say that as well. Right? You could put halogenation for that as well. Right? But the third reaction is what we call combustion. And then we have a fourth reaction here. You're converting compound A into compound D. What about reaction 4? Alright, so I see you all putting correcting polymerization. Alright, so reaction 4 is a polymerization reaction. Right? Notice I spelled the word with an S. So CXC, they keep interchanging between S and Z. S is the British spelling, Z is American spelling, right? We follow British, so it's S, right? But CXC, they use it interchangeably. Right, so somebody asked me what is reflux, right? Let me just go back here for a sec. So you all have to be able to draw what a reflux apparatus looks like. So it's this. You have a tube, right? A condenser, sorry, right? And you have a round bottom flask. So I just run this freehand, so it may not be the best, right? And what you have here is your acid and your alcohol, right? And you are heating this, right? But at the top of this thing here, right? At the top of this thing here, right? You have this condenser at the top here, right? So this here is a condenser. What happens is that alcohol is volatile. So when you start to boil this thing, what's going to happen? The alcohol wants to evaporate. So you need to put a condenser at the top here. So as fast as the alcohol is evaporating, it comes back into the mixture, right? So that's what our reflux apparatus is. You all have to be able to draw that in the exam, by the way. They can ask you that, right? So who had asked me that way? I can't find it here. Somebody had asked me that just now, right? That was Faith. What is reflux? That's what it is. Alright, so we're still on January 2021. This question is still going on, right? Identify suitable reagents and reaction conditions for each of the following conversions. So you want to go from compound A to compound B. So let's go back to our diagram. Compound A to compound B, that was this reaction here. And that's a hydrogenation reaction. So here's what you need for that reaction, guys. You need hydrogen gas, so H2 gas, right? You also need something called a nickel catalyst. You need to learn these things off. So it's called a nickel catalyst, right? And apart from that, you need an appropriate temperature in which to do that, right? Now, if you want to do that, you need a temperature of about 150 degrees Celsius, right? So nickel catalyst, 150 degrees Celsius, around it. Right? Some of you all might put 170, 180. They still give you the mark. Right? So when they say reagent, look what they said. Suitable reagent and conditions. Right? So you need hydrogen gas. That's my reagent. And I need a nickel catalyst and a temperature of 150 degrees. So that's what they want for the answer there. Right? You want to go from compound A to compound C. Let's go back to the diagram. So A to C is this reaction here. That's reaction 2. And what you're doing here, you are adding bromine across the double bond, right? So that's what you're doing here, adding bromine across the double bond, right? So all we need to do is to add bromine, right? So we have two options here. We have two options here to do that. So you can add bromine in water, That's one way we can do this, right? Or you can add bromine in something called tetrachloromethane, right? Or what we call CCl4, right? So either you give this here, you say bromine in water, which is the easiest one to use, or bromine in tetrachloromethane. So this bromine we're talking about here is Br2, guys, right? And this particular reaction, you don't require no UV light. This reaction can take place in the dark, right? So you can mention that. You can say reaction, right, takes place in the dark at room temperature, right? When it comes to an alkene, you have a different reaction. You require UV light in order for that reaction to take place. But this particular reaction, this reaction can take place at room temperature and it can take place in the dark. So this is one of those reactions where, or what we use to distinguish between an alkene and an alkene, right? You get decolorization of bromine. So reddish brown to colorless, right? So also Janelle mentioned that there. The solution will decolorize when it's added. So that's true, right? That's a test that we use to differentiate between an alkene and an alkene, right? All right, so for those of you now joining us here, right, all I ask that you do is subscribe to the channel. So if you haven't done so as yet, subscribe and hit like, right? And feel free to share to any and anybody that you want to, right? Now, we're still in January 2021. They said given that the R in the ethyl group, R is the ethyl group. So look, remember in one of the questions I said the R group is given by this, CnH2n plus 1. Now they are telling us that this R group here is called the ethyl group. So if it's the ethyl group, ETHYL, that group has 2 carbons in it. So it's C2, 2 2s are 4 and 1 5. So this here, C2H5, is my ethyl group. They want to know what is the molecular formula for compound A. So let's go back and see what A look like. So this is A here. This is what A is, right? So let me just draw it across here. So this is what A look like, right? So you had an R, then you had a C, right? So this was compound A here. And if you want to write the formula, all you need to do is to replace this R with this here, this C2H5. So this compound here is going to be C2H5, right? And it's going to look like this, right? So this is my compound E. That's what it is. So they want state the molecular formula. So if we just look at this compound here, right? I'm going to write it down. It only has carbon and hydrogen. In total, we have 2 carbons, 2, 3, 4. We have 4 carbons. And then when we look at the hydrogen, we have 5, 6, 7, 8. So this here is my formula, molecular formula for compound A, C4H8. Now they said hence write a balanced chemical reaction for reaction 3. What was reaction 3 now? So reaction 3 was combustion. So what I'm going to do, I'm going to take compound A and I'm going to combust it. So it's C4H8 plus O2, that's oxygen gas, and that's going to give me CO2 gas plus H2O liquid. That's what I'm going to get when I burn this compound. Now, how I taught my students in class how to balance this. We have 4 carbons on the left, so I need to put a 4 here. You have 8 hydrogen, so we're going to put a 4 here. Now we need to see the number of oxygens are balanced now. On the right hand side, you have 4 2s are 8 and 4 12. Therefore, all I need to do is to put a 6 in front of this in order to balance this equation. See when CSEC says write a balanced equation, you're getting marks for that. So if it's not balanced, you're going to lose marks. Now, the last part here, I think is the last part, hopefully, is it? Yeah, I think that's the last part. Describe a chemical test that can be used to distinguish between compound A and B. So, it's a popular question CXC brings. Compound B, this compound up here, it's an alkene. Right? That's an alkene. And compound A is an alkene. So what they are asking us here is to describe a test to distinguish between an alkene and an alkene. Now, here's the problem. Some students, they know what the test is, but in terms of what they write down as the answer, they lose marks easily. So what we can do, we can use the same bromine water that we had just now, right? So here's what you're going to do. You're going to add bromine water right? That's essentially bromine mixed up with water, that's all. Right? Add bromine water to compound A. So this is what you're writing, So compound A and compound B. Right? So you're adding it to both compound A and compound B. Right? Now you need to say what's going to happen to each of those. So in the case of compound A, so you need to say what's going to happen now. So compound A, remember compound A was an alkene, right? Compound A was an alkene. Let's double check that, make sure I tell you the correct thing. Yeah, compound A is the alkene. So let's go back here. So compound A is the alkene, right? So compound A decolorizes right, the bromine water, right? And what you should do is state what color change is taking place, right? So reddish brown to colorless, right? So this is what's going to happen to compound A. You need to say what's going to happen to compound B, because that is what is going to allow us to differentiate between the two of them. So no reaction or no color change with compound B. So no color change So this is the part that students, they miss out and end up losing a mark just for not writing this down, right? So no color change with compound B, right? So 4 marks for that. So you need to state what the reagent is and what's going to happen to each of these here, okay? Alright, somebody asked me about the state symbols. You can put in the state symbols if you want to. So this one here, C4H8, right? This could be a gas. This is oxygen gas, right? This is gas, and this here is liquid, right? So you can put in the state symbols if you want, right? Sometimes they're very specific and they ask you for the state symbols, right? Especially when it comes to ionic equations, you have to put state symbols. Right, so let's see. So this is June 2014 now. So look again, look how many times they've asked us what structural isomers are, right? So again, I'm not going to write what it is here because we've met it like about twice already. So structural isomers, same molecular formula, different structural formula, right? So let's see what's going on here with this one here, June 2014. So they said molecules with the formula C4H8 can exist as structural isomers. So the formula of some compound is C4H10, sorry, right? And they want you to draw the fully displaced structures of 2 isomers with formula C4H10. So what you could do, you can just draw a straight chain first of all that has 4 carbon atoms, right? So this is one structure. So this is one isomer here. Right, isomer 2 now, all we need to do, we could try to create a branch isomer. So we can do this. Let's put a C here. right? So this is a branch isomer here. So these are two structures. Both of them have formula C4H8. And look at how many marks for this, 4 marks for this. That's easy marks in the exam if you know what an isomer is, right? So that's structural isomers. Now again, well, look at this. You realize they tend to ask the same things over and over. You have two hydrocarbons, compound A, compound B. Obviously, we can tell that this is an alkene. This here is an alkene because we have a double bond. This here is an alkene. So just like in the previous question now, they said briefly describe one test to distinguish between compound A and compound B. So what we need to do, we need to add bromine water to both of them. So A and B, that's what you're going to do. And then you need to state what the observation is. So in the case of A, because it's an alkene, rapid decolorization. Right? So we go from reddish brown to colorless. So reddish brown. Right? And in the case of B, we get no reaction, right? Or no color change, right? Now this is one reagent that we could use. There's a second test that you could use. You can use acidified KMnO4, right? This is another reagent that we could use to differentiate between an alkane and an alkene. In the case of compound A, right, it's going to decolorize, right? And in the case of compound B, you don't have any decolorization taking place, right? Now the KMnO4 is purple, so the color change we get in here is purple to colorless, right? So this here, we're going to get a reaction, but it's purple to colorless, right? And this one here is no reaction or no color change, right? So please make sure you know how to differentiate between an alkane and an alkene, right? So you have two tests you can choose from. Use bromine water, right? Or you can use acidified potassium manganate 7, right? So they said compound A and compound B burn in oxygen, right? A balanced chemical equation for compound B in excess oxygen. What is compound B? Right, so we need to look at this compound B here, and this has a formula of C3H8. That's my formula, right? So you want to write an equation for combustion. So it's C3H8, so if you all want the state symbols, I'll write it in, plus oxygen gas, right? Produces, you will always get carbon dioxide gas plus H2O liquid. Now let me show you how to balance this, right? Some people have problems balancing this, but there's a technique that I use so you can balance any equation they give you. So you have 3 carbons on the left, so you're going to put a 3 here. You have 8 hydrogen on the left hand side, so we're going to put a 4 here. Now let's look at the oxygen. On this side here you have 3 by 2, that's 6, right? And then you have 4 by 1, so that's 4. So therefore you have a total of 10 oxygen on the right hand side. So therefore if I need to balance this, all I need to do is to put a 5 in front of this, right? So that's my balance equation for the combustion of compound B. Now, they want us to state a use for compound A and compound B. Now, what was compound A? Compound A, 1, 2, 3, that's 1 propene. So compound A is 1 propene, right? And compound B, the name of compound B was 1, 2, 3, is propane. right? So one use, right? In the case of propane, propane is what you use in a gas tank in a kitchen, right? So cooking gas, right? In the case of propene, you can use that to make an ester, right? So you can say used make the ester, right? Alkenes can be used to make an ester by addition polymerization. So use the ester called polypropene, right? So that's what we use propene for. You could use that to make the ester polypropene, right? Now, what do we have here now? So we have compound A. This is compound A here. It's an alkene, and that is being converted into, it's an alcohol. So this here is an alkene, right? And this compound here is an alcohol, right? Now, they want us to identify what is this X here. What am I adding there, right? So compound X, right? When you convert an alkene into an alcohol, basically what you're adding here, you are adding water or you're adding steam, right? So you can put this H2O gas, right? Or you can say steam, right? That is how we convert compound A into compound D, right? Now this says state the name of compound A and the homologous series to which it belongs. So compound A, don't just go and tell the people it's propanol. In this particular case here, it's called 2-propanol, right? Or you can call it prop and dash 2-ol. That's the name, that's the other name for it, right? Do not put propanol. If you put propanol alone, you will not get a mark, right? You will not get a mark. And the homologous series, all you need to tell them here is the alcohol, right? 15 marks. So each of the questions in the paper is going to be worth 15 marks, guys, right? So like I said, you're going to get 2 questions concerning organic chemistry. At least that's how it's been over the past few years, right? All right, so we still, this was what? This was June 2014, this is January 2014. So they give us some compounds here, compound A, compound B, compound C. State the name of the homologous series to which of the compounds belong. Right, so compound B, that's this one here, that's an alkene. Right, compound C now is this one here, that's a carboxylic acid. So this here is a carboxylic acid. That's what this is, right? It's a carboxylic acid. Then part B now, compound A burns with a blue flame, right? Compound A, this compound here is ethanol, right? This compound here is ethanol. It does burn with a clean blue flame. If you ever try to light some rum, you're not going to see it burn. So compound A burns with a clean blue flame. Write a balance equation for this reaction. So ethanol, you can write the formula as C2H5OH, right? If you all want state symbols, this will be aqueous plus O2 gas. When you burn ethanol, you're only going to get 2 products, that's CO2 gas, right, plus H2O liquid, right? Those are my products, right? Now, if we have to balance that equation, so all we need to do is to put 2, we need to put a 2 here, we need to put a 3 here, and that'll be 2 to the 4, so we just need to put a 3 here, right? Because I said I want a balance equation, so please make sure you are able to balance an equation, right? That is absolutely required for you guys. So let's see what else they want here. State which of the two compounds, A or B, is more soluble in water and give a reason for your answer. Right? Which of the following is more soluble in water, A or B? So let's go and see. Compound A is the alcohol and compound B is my alkene. Right? So which one do you all think is more soluble? Is ethanol more soluble than this compound? Is 1, 2, 3, 4, 5. That's pentene. Which is more soluble, ethanol or pentene? Right, Sharice is telling me it's ethanol. That's correct. Ethanol is more soluble. So which one? So it's compound A. So compound A is more soluble, right? So Sharice is in my class, so she should know what the answer is, right? They want to know why. Why is ethanol soluble in water, more soluble than pentene, right? Now that has to do with the fact that the OH group, so you need to say this, the OH group in the, let's put in compound A. In compound A is polar, right? That's what we need to say, right? So the OH group in compound A is polar. Water is a polar solvent. Right? So if you all remember your chemistry from, let's say, Form 4, water is a polar solvent because of this. A water molecule looks like this. You have O and 2 OH attached to it. But the problem is oxygen is more electronegative than hydrogen. So there's a small shift in this electron pair here, and you end up with a small negative charge here, a small positive charge here, and a small positive charge here. Right? So water is a polar solvent. Now you don't need to draw all of this for your answer. All you need to say is water is a polar solvent. So the OH group, forms bonds with water molecules therefore making it soluble. Right? So this is what we have here. That's your answer. You need to say that the OH group is polar, right? And you need to say water is a polar solvent, and therefore the OH group is able to form bonds with the water molecules. Now this question has come many times in the exam, right? But this is the answer that you need to give in order to get the marks, right? So now they want to know which compound A or compound C, reacts more vigorously with sodium metal, and give a reason for your choice, right? So you have compound A, that's this compound here, which is an alcohol, and compound C. Now both of those compounds technically can react with sodium, right? So if you all would have done this in school, you need to know that sodium could react with ethanol to give me sodium ethoxide. Sodium could also react with ethanoic acid. In this case, sorry, this is not ethanoic acid, this is propanoic acid. So sodium can react with both of them, right? So they want to know which one is it more reactive with. So obviously it's going to be more reactive with the carboxylic acid. So it has to be compound C. So it's compound C, right? And the reason why is that compound C, right, is a stronger acid, right, than compound E, right? Now, we know that propanoic acid is a weak acid, right? But what we're doing, we're comparing compound C and compound A. That's why I'm using the word stronger in that sense, right? These acids are what we call weak acids, and they are partially ionized in aqueous solution, right? But what I'm doing, I'm comparing compound A, which is an alcohol, and I'm comparing compound C, which is a carboxylic acid, right? And they want us to write a balance equation for the reaction of compound C. So that compound is, so here's what I like to do when they give me a structure like this. I typically draw the structure and try to draw the reaction. So what I'm having here is this. So you have this is my acid, this is my propanoic acid, that's compound C. And I'm reacting that with sodium. So you're reacting that with sodium. So this here is going to be aqueous, and this is sodium solid, right? But what's going to happen is that that sodium is going to displace this H here. So the compound that I'm going to get is C O minus Na plus right, plus what is going to happen, you're going to get H2 gas. That's going to be my product here, right? This here is aqueous, by the way, right? Now, as it stands here, this equation is not balanced, and what you need to do to balance it is to put a 2 here, and we also need a 2 in front of this, right? So if you check any chemistry textbooks, right, you're going to see this equation there. So what we're doing, this particular reaction is what we call a redox reaction, right? Or an acid and a metal is going to give me a salt and hydrogen gas. That's what's happening here. So the name of this compound here is called sodium. It's propanoic acid, so it's called sodium propanoate. Right? That's the name of this compound here. Jada is asking if it has more H plus ions. Not necessarily, not really true, right? What happens is that the ethanol, right, is partially ionized, just like the propanoic acid, but it's so weakly ionized, it makes the propanoic acid much stronger, right? That's what's happening there. And they said, describe one test that can be used to identify the gas that is produced when compound C reacts with sodium. So if you go back to this equation, this is my gas. I'm producing hydrogen gas. So when it comes to a test, right, what we do, we place a lighted splint in the gas. Right? Now, one of the things that CSEC complains about is that students, they know what the test is, but they don't explain what's supposed to happen. So this is my test. I'm going to add or place a lighted splint in the gas, but you also need to say what a positive test is, right? So a positive test, right? What is going to happen is that you get a squeaky pop. Right? If hydrogen gas is present, you're going to get a squeaky pop. So apart from describing a test, you need to state what is actually happening. Right? That's what you need to do. Now, they said A and C react together in the presence of a catalyst to form compound D. Right? What is A and C? So let's go back to the diagram here. What is A and C? Compound, that's not, I went back too far. Right, so compound A and C. So this is an alcohol and an acid. So therefore, when I add those two things together, I'm going to get an ester. Right? So they want to know the name of the catalyst. So we met a question like this before. The catalyst is concentrated sulfuric acid. right? And you're reacting ethanol and propanoic acid. So when you draw any structure, guys, always draw the acid first. So I'm going to draw propanoic acid first. So this is what my propanoic acid looks like. So the first part of the ester comes from the acid part, right? Then we have to draw the alcohol part now. The alcohol was ethanol. So therefore, this is what my structure of my ester is going to look like, right? So all they want us to do is to draw it. They didn't ask us to name it, right? If they had asked us to name it, then the name of this would have been ethyl, ethyl propanoate. Right? That's the name of the ester in this particular case here. Right? Alright guys, so we've done several questions here on organic chem, right? Let me see how many. I'm going to do one more, but let me see. Yeah, no, I think I'll pause there, right? So we've done several questions here, a few years past papers on organic chemistry. So please listen, listen to what I'm saying when it comes to organic chem. You all need to revise your work. It is a very easy question, right? And like I said, you're going to get 2 questions on the paper. So please review your notes, right? This is something that you can get easy marks on, right? What happens is that a lot of students, they leave this for last and they don't spend much time studying organic chemistry. But like I tell you all, it is very, very easy and you should try to attempt the organic chemistry questions, right? So guys, this is it for me for today, right? So for the entire month of June, I am doing some free sessions, and that's in CSEC Maths, Chemistry and Physics. Chemistry is on a Monday, Maths is on a Tuesday, and Physics is on a Wednesday, right? We already had 1 math session and 1 physics session. So tomorrow I have a math session, right, at 3 o'clock tomorrow. So guys, enjoy the rest of your afternoon, and if you haven't done so as yet, you go ahead and hit like, subscribe to the channel. You also can forward it to anybody you want, right, who's in your class. And that's it for me guys. Enjoy the rest of your evening.